when you are writing an inverse, because you will be asked to do that on your Regents somewhere, you have to know step one is to do what? Say it again. Flip the x and the y. So rather than y equals this nonsense, we're going to say x equals 2 root y minus 3 plus 1. And then, and this one's an easier process to memorize because only 2 steps. Switch the x's and y's and then solve for y. Yep. So what do I do first to both sides, Natalie? I'm trying to get y all by itself. So I got to start eliminating stuff on this side. Subtract the 1. Next. Vince, what would you like to do next? Divide by 2. And you can. You definitely can. I'll do it. I'm going to also rewrite where we are right here, and I'll show you it both ways. But divide by 2 is fine. Unfortunately, it doesn't divide nicely. I'll just leave it like that. Rather than making it a half of an x minus a half, I'd rather do this. Next. Eric? Yep. When you square this fraction, definitely lock it up in parentheses. And again, we're not going to really do that out. And then we're just adding our 3 to both sides, yes? So add 3, so I'll put it over here. Y equals x minus 1 over 2 squared plus a 3. And because this started off as f of x equals, I really will lose a point if I keep it as a y. You have to use the appropriate notation, which is f inverse of x equals Owen. I had this minus 3 I had to get rid of, so I had to add 3 to both sides. Chloe?
If you didn't divide by 2, how would you do it then?
Okay, I'm going to show you that right here. Okay? So if I didn't divide by 2 because I didn't like the fraction, I would just square both sides now. And on my right-hand side, that would become 4, and then y minus 3. And then you tell me, Chloe, what would you do from here? You know what? You don't really, I mean, you could, but that would just be more simplifying. Our goal is to focus on how are we going to get the y all by itself. So don't even look at that side. How are we going to get this y all by itself? Distribute the 4. And then, what would you do next, Chloe? What? If I told you to try to get this y all by itself, did you just say you don't know? Yeah, baloney. I thought so. Add 12. And then divide both sides by 4, which you would probably see this in this format. The parentheses squared divided by 4 would actually probably look and be presented like that. 1/4 x minus 1 squared, and plus 12 over 4 would be plus 3. Those two presentations of answers, and again, I'd make this f inverse of x. I just did this 2 ways, and my answers look very different. Can we all agree with that? So that is one thing, is particularly if it's a multiple choice, you want to be able to see other options of how to solve that. Okay? One other thing you could do if it was multiple choice, and let's say we did it this way, but that wasn't an option and we couldn't quite make the connection between this one and we didn't really see the other way of doing it. Inverses, when you graph them, should be reflections of each other over that diagonal line y equals x. Yes? We talked about that on our inverse day. So if you know what your original function looks like, and just watch here, I will plot this. Just a quick, it's not really a side question because it is something that's going to play into an important point here. What is our domain of this function? Our x's all have to be what? Maybe the graph would give you a hint. Our x values are all greater than or equal to what number? 3. Because this parent graph got shifted 3 to the right, if you want to look at it that way. Or because anytime you take the square root of something, it has to be greater than or equal to 0. Okay? So that's important. I'm going to write that down, that your x has to be greater than or equal to 3. That's the domain of your original. So what does that tell you about your inverse? If in your original x has to be greater than or equal to 3, what does that tell you about your inverse? Remember, all things x's and y's flip-flop. Right. So if x has to be greater, who said that? Oh, you did. I thought you did. But then I was like, wait, is there a mouth moving or maybe you just had it covered up? Okay. In your original, if x has to be greater than or equal to 3, then in your inverse, y has to be greater than or equal to 3 because all things flip-flop. So when I graph this inverse function, and I'll just do this version of it, 1/4 x minus 1 squared plus 3. What you're going to notice, well, I don't know. Hold on, I want to say one more thing before I can show you that graph and you get confused. Going back to just our original graph, not only is that our domain, but what's our range here? What do our y's have to be on the original? Greater than or equal to 2, yes, because there was a stretch vertically by 2 and then a shift up 1. If you look at your table and you want to see that it's not actually 2, it's 1. Yeah, and I know that because if you think about this point and the transformation it undergoes, it first moves right 3, which is here. Then it stretches vertically by 2, which actually is not going to move it because it's already on the x-axis. And then it shifts up 1. You're right, though. The graph does kind of look like it's at 2, but that's because the graph doesn't really pull it down. That's like a pixel issue. So you don't really ever want to trust the graph, especially at an endpoint like that. So it's actually 1. So if that's the range of your original, that's going to turn into the domain of your inverse. Follow? So now watch what happens when I graph the inverse. What happened is, does it look like the graph, that parabola that just came up is a reflection of this piece? No, it doesn't, because it's too much. And it's too much because there's no way to write these restrictions that we just thought through into your calculator. But the reality is that because this domain was greater than or equal to 3, this range is going to be greater than or equal to 3. And that did happen. This is greater than or equal to 3 on the range. But because this range had to be greater than or equal to 1, this domain has to be greater than or equal to 1. And that's something we can't tell the calculator. We just have to know. Here's 1. And we're really only allowed to look at that when it's greater than or equal to 1. Now, do those two look like they're a reflection across the line y equals x? Yes. So the whole flip-flop over the x equals y axis can get tricky in general to kind of wrap your head around how that is still happening when we have limited domain situations. Because a limited domain situation is going to usually produce a limited range situation, which you have to keep in mind when you're looking at the graph of the inverse. Are we good? Okay. All right, so there's writing an inverse and also thinking about how a limited domain in the beginning can create an issue with a limited domain and range at the end. All right? To fill in that blank there, we're just going to say y equals x, because we're reflecting it over that line y equals x. Okay? And then your last two are going to be pretty straightforward. Definitely that multiple choice one. So I want to switch to this next question, which was on the August 2017 Regents. And here's what I'm talking about. It's another solving one. I don't need to teach you anything here. I've already taught you how to do these. It's just another opportunity to practice. This is the caliber of a Regents question. So step one is what tests for all radical equations? Okay, so what would I need to do in this equation to get one of them alone? Perfect. Yep. And second step is to square both sides, which is easy on the left, a little bit more challenging on the right. Yes? The left is just x plus 14. The right, I actually really kind of need to visualize the FOILing process. 1 times 1 is 1. 1 times root 2x plus 5 is just root 2x plus 5. Just like any coefficient of 1, I don't really have to write it. Root 2x plus 5 times 1 is another plus root 2x plus 5. And then root 2x plus 5 times root 2x plus 5 is just going to be 2x plus 5. So if I combine like terms now, 1 plus 5 is going to give me a 6. A root 2x plus 5 plus another root 2x plus 5 is going to give me how many of them? 2 of them. And then I have to take the process from the top, right? Re-isolate the radical, square both sides, and then that other radical will work its way out. Okay? Your homework tonight, we're not going to finish this one, is to finish the worksheet. At the bottom there, 4A and 4B, there's not much room. Put those on a separate sheet of paper. The one I want to talk about quickly before you go is the system one. We didn't do another system today. We did one yesterday on the notes. This says y equals root x plus 10, yes? This other one is a linear. It doesn't say y equals, but it is a line. I essentially need to take this root x plus 10. Since it equals y, I'm going to plug it in for y down here. Is that clear? Substitution. So it's going to be x minus the square root equals -4, and that's what I'm solving to find x first. Once I find x, I go back and find y.